All right, let's do the first example of testing claim using the 7-step process for hypothesis testing. Okay, and here's my first step. I need to state the claim mathematically. Okay, and then I need to label the claims as HO and H1 or HA. And basically what I had to do is read this word problem and underline where is the claim. And it says here that a manufacturer claims that its rechargeable batteries are good for an average of more than 1,000 charges. A random sample of 100 batteries has a mean life of 1,002 charges. Assume the population standard deviation is 14. Is there enough evidence to support this claim at alpha equal 0.01? So, since my first step is to identify the claim, I notice that after the word claim, it comes what I need to underline. So what I need to underline after this word claim, that the average of the batteries is more than 1,000 charges. And what I had to do, since that is my claim in words, my first step is to translate the claim from word into math. Average is the mean. We're working with the population mean, so mu. More than, that means greater. 1,000, and I'm going to put in parentheses the word claim. Okay, that's my first step. Now, every claim, don't forget that every claim has a counterclaim, so I need to state the opposite of my original claim. So what is the opposite of being greater than? That will be less than or equal. That's the opposite of greater than. And then I'm going to put here 1,000. So I'm just stating the opposite of my original claim. That will be my counterclaim. Now that I have my two claims, counterclaim and original claim, I need to label them as HO or H1 or HA. Anything that has the equal, any claim that contains the equal will be labeled as HO. That's what I'm doing right now. Okay, so the top one, because it has the equal, will be labeled HO. The bottom one doesn't have the equal. We label that as H1 or HA. And there's my first step. Step number 2, specify the level of significance. Basically, what you have to do here is find out how much is alpha. And my alpha, you can see it here, is 0.01. That's all what you have to do in step 2. Step 3. Okay, according to step 3, that's when we're going to do the picture. We're going to draw the bell-shaped curve. So here's my bell-shaped curve. All right. And I need to decide which tail I'm going to shade. Who decide the tail we're going to shade? H1. Okay, that's the one who decide that. And look at the inequality symbol. It's greater than. That means we're shading to the right. So that's my right tail. That's what I'm shading. Okay, the right tail. All right, and we did step 3. Step 4, according to the steps, we're going to calculate the test statistic, which basically that was one of these formulas. See, I need to use a formula. Now, which formula I'm using? Well, it depends on what you're testing for. Well, in my case, my claims is about the mean. So we're testing for the population mean. So it's going to be the first one or the second formula. See, one of these two. Now, how do I know which of these two I choose? It depends on what information extra you have. And what do I know? Well, I know that the population standard deviation is 14. And if you look here in this column, I will use the first formula, okay, the one that says Z equal, because I know sigma. I know the standard deviation of the population. So I'm using this formula here. So let me write it out. Z equal, okay, X bar minus mu divided by sigma over square root of n. And what I do, I'm going to plug in this formula. Okay, so who's my X bar? That will be 1,002. That's my X bar because I'm working with samples, okay? Minus my mean, my mu, that comes from the claim. You can see the claim is 1,000. So that's what I'm going to write here. Divide that by sigma. Sigma is the population standard deviation, which is 14. And then that 14, I need to divide it by the square root of the sample size. How big was the sample? It says here 100. And then what I suggest, you use decimals. That's what I'm going to do next. I'm going to use decimals. So I'm going to get decimals. Here's decimals. I'm going to click on the fraction bar, and I'm going to type exactly what I see here. So 1002 minus 1000 divided by, I have another fraction on the bottom, 14 over the square root of 100. And you can see here I got 1 point, I need to round to 2 decimal places because that's a z-score, 1.43. So that's how much is my test statistic. Now, why do I need this number? This number is going to be the label of this mark here. So this mark here is 1.43. Okay, that's what I need step 4, because that will be the label of the mark where I start shading the tail. Now we're going to go step 5. Okay, and what is step 5? Step 5 is find the p-value. And how do you find the p-value? Well, we want to find out how much is shaded there, the tail. Now, because my step 4 I was working with Z, I'm going to be using the normal calculator. Oops, not that one. Where's my normal calculator? Right there. Okay, I'm going to use this calculator. And where is shaded? To the right. So make sure the drop down menu, choose to the right. And you're going to type in the blue box 1.43. And then hit enter. And you can see how much is shaded. I'm going to round to 4 decimal places, so it will be 0. Oops, I missed that one. Let me look at it again. 0764, 0764, and that's step number 5. The p-value. What is the p-value? How much is shaded in the tail? So 0.0764. And I did step number 5. Now he go with step number 6. And what is step number 6? I'm going to make the decision. Okay. And what I do is I'm going to compare the p-value. I'm going to compare that against the alpha, the level of significance. And who was my p-value? 0.0764. Who is my alpha? 0.01. See, that was from step 2 up here. See, and the p-value step 5. And then from left to right is the p-value. Is this decimal 0.0764 bigger or smaller than 0.01? Well, in our case, it's going to be bigger. This number is bigger than that. So according to step, I'm going to show you the slide. According to this chart, when the p-value is bigger than alpha, our decision is going to be fail to reject HO. That's what I'm going to do. Or right here, fail to reject HO. Okay. And we did step number 6. We're almost done. Now we're going to do step number 7. We're going to make the interpretation. And how do we make the interpretation? That's when we use this chart. Okay. And step number 7, the way I make the interpretation is I need 2 things. I need to know what was my decision. Our decision was fail to reject. So it will be the second one here. Do not reject HO. So I'm in the second row. And the second thing I need to know is where is my original claim. That's what I put the parenthesis, in parenthesis, the word claim when I translated the claim from Word into math, the original claim. And my original claim is in H1, which is the same thing as HA. So I'm in the second row, last column. So where you see the intersection of the second row and last column, whatever you have there, that's your interpretation. So my interpretation will be there is not enough evidence to support the claim. Let me write that out here. There is not enough evidence to support the claim. Oops, I spell it out incorrectly. Support the claim. Okay, and again, how did I get that? My decision was fail to reject, which is the same thing as do not reject. And my last is my original claim is in H1 or HA, so I'm in the second row, last column. So this is my um, interpretation. Okay, not enough evidence to support the claim. I hope this helps.